This is section 6.3, which is over the law of cosines, and this is the last section that we will cover in this chapter. Here are the objectives. In this case, we will now be using a different law, the law of cosines, to solve triangles. We will also use Heron's formula to compute area. So as mentioned in the previous section, there are a few forms of oblique triangles that we will have to use the law of cosines to solve rather than the law of sines. The reason for this is because in order to use the law of sines, we need to have a complete ratio. But in these two cases, side angle side or side side side, we don't have this complete ratio. So we need another method of solving, and that's the law of cosines. So here is the information regarding the law of cosines. And basically, it takes this form here, and it looks kind of complicated, but if you pause the video, you can see the things that are common in each of these different forms. So if we want to find a side, this form is helpful. If we want to find an angle, this form is helpful. But either way is fine, and we will just jump into how to use this. So you can pause this and take a moment to read through it if you want, but when we are dealing with the law of sines, anytime we are dealing with the law of sines, we will want to find the measure of the angle that has the smallest angle, basically. So anytime you're dealing with the law of sines, use the smallest angle first, and then you can use the law of cosines. And I'll kind of show you what I mean. All right, let's just jump into an example because I think it will be helpful to see it. Now I want to show you why we are unable to use the law of sines here. In order to use the law of sines, I would have to have side A, angle C, or angle B. And I don't have any of those. So this is why I need to use the law of cosines. So given the law of cosines, I will need to find the side A first. So just a reminder of what that formula is. It's a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A. The reason I have to find A is because the only angle that I'm given is angle A. So I'll find side A. Plugging in this information into the formula, we get a squared equals 19 squared plus 22 squared minus 2 times 19 times 22 times cosine of 38 degrees. Make sure your calculator's in degree mode. So when you plug this in, you'll find that a squared is approximately 186.22. Then to get a by itself, you will take the square root of both sides. Since we are talking about a length of the side of a triangle, we want the positive outcome. So a is approximately 13.646. Now, I want to remind you of something. When we have a triangle, the longest side is across from the biggest angle. The smallest side is across from the smallest angle. And that's going to be helpful when we continue to solve. So the next step here is to either use the law of sines to find angle B, because angle B is smaller than angle C, as just explained, or we can use the law of cosines and we can find either A or B. So it's really up to you which approach to take. So let me just sketch this picture, and this is how it was labeled on the previous slide. So this is 38, 19, and 22, and then we just found this other side to be 13.646. So I'll show you both methods, okay? So the law of sines and then the law of cosines. So the law of sines, I would have to use what I just found for the side of A, and I'll want to try to not use the approximated value. Otherwise, the angle that I find for B will be maybe off due to rounding. So I'll have the sine of 38 degrees divided by 13.646 is equal to sine of B, and again I'm finding B because I know it's smaller than C, divided by 19. We've done this before. We'll cross multiply and we'll find that angle B is approximately 59 degrees. Okay, well, I can solve this using the law of cosines as well. Since I'm finding an angle measure, the form cosine of B is equal to a squared plus c squared minus b squared. This form will probably be the most helpful. So when I plug in this information, cosine of B is equal to, again, I'm using this value that I just found. And you can store this decimal value into your calculator, which would be wise to figure out how to do. That way you're not always approximating. Okay, and then just evaluate this and you'll end up getting the same angle measure as the others. Then once you find that, then we need to find the last angle, which should be pretty straightforward. We'll take 180 minus the angle that was given minus the one that we just found, and you'll find that that missing angle is 83 degrees. Go ahead and try this one on your own and see if you can solve it correctly. First thing I would recommend doing is sketching a picture. It's what we've done throughout this chapter. And this is the given information. We do not have a complete ratio provided, so we are unable to use the law of sines. We can, however, use the law of cosines, and when I do, the only angle I'm given is angle B, which tells me I will have to find side B given this information. Plugging this in, you'll have 19 squared plus 28 squared minus 19 times 28 times cosine of 61 degrees. So B squared is equal to 629.16. We will then take the square root of both sides and find that B is approximately 25.08 or 25.1. Okay, so we have found that this side is 25.1, so I can proceed with either using the law of sines or the law of cosines. Either way is fine. If you proceed with using the law of sines, I would recommend finding C first because I know that angle is smaller, and the law of sines always produces the acute angle. So I'll just go ahead and use that. So I'll take sine of 61 degrees divided by 25.1 is equal to sine of C divided by 19. So sine of C is approximately 0.662. Taking the inverse sine of both sides, I'll find that C is approximately 41.5 degrees. You can find angle C by using the law of cosines as well if you choose. Then the last thing I need to do is find angle A, and that is found by subtracting the given angle and the angle we just found from 180, and this will give us 77.5 degrees. All right, well, if we have a side, side, side case, here are the steps to solving using the law of cosines here. And you can pause this and read through it, but I'll just go ahead and show you how it's done. All right, so here we want to solve this, and as you can see, we are given only the sides of the triangle. So we must use the law of cosines because we don't even have an angle to apply the law of sines. Now, the first thing I'm going to do is I'm going to find angle C. The reason I'm going to do that is because the law of cosines will allow me to find obtuse angles. And I know that angle C is the largest angle because it is across from the largest side. So in the side, side, side case, always find the largest angle first. So the form that I'm going to use is cosine of C is equal to 10 squared plus 8.7 squared minus 12.3 squared, all divided by 2 times 10 times 8.7. This is equal to 24.4 divided by 174, which is 0.14023 approximately. I'll take cos inverse of this, and when I do, I find that C is approximately 81.9389 degrees. Great. Okay, so we have found this. Now we either need to find angle A or angle B. When we find angle A or B, we can use either the law of cosines or the law of sines. Either way is fine. Let's say I use the law of sines. If I use the law of sines, then I want to find the angle, the smallest angle first. So let me just sketch this picture one more time. So this is 81.9 we just found. This side is 8.7, 12.3, and 10. Okay, so if I'm going to use the law of sines, I know that angle B is across from the shortest side. So I'm going to find angle B using the law of sines. I also have to use this information here for my other ratio. So using that, I have sine of 81.9 degrees, and I'm going to try to use the exact value rather than the rounded value there, divided by 12.3 is equal to sine of B divided by 8.7. So B is equal to sine inverse of 8.7 sine of 81.9 degrees divided by 12.3. Plugging this into my calculator, I find that B is approximately 44.5 degrees. Okay, so again, if you use the law of sines, find the smaller angle first. You could also use the law of cosines. So if you wanted to find angle B or angle A, it doesn't matter, you would plug into this formula. So 10 squared plus 12.3 squared minus 8.7 squared divided by 2 times 10 times 12.3. When you plug this into your calculator and you take cos inverse of both sides, you'll end up with the same value for angle B. Okay. The third and final step of solving this triangle is to find the last angle. So to find angle A, we'll take 180 degrees minus the two angles that we just found. One was approximately 81.9, the other one was approximately 44.5. So angle A is approximately 53.6 degrees. Not so bad. Go ahead and try this one on your own. As discussed, let's go ahead and label our triangle. I'm very visual, so I think it's helpful to see this. Okay, so looking at this, once I have this sketched, I always think it's nice to think about which angle is going to be the biggest and which angle is going to be the smallest. I know that angle A is going to be the biggest because it's across from the biggest side. On the other hand, I know that angle C is going to be the smallest because it is across from the smallest side. When I am solving this, I always want to find the largest angle first. The largest angle first is found by using the law of cosines. So applying that law, the formula is cosine of A is equal to 48 squared plus 41 squared minus 62 squared, all divided by 2 times 48 times 41. When I plug the numerator into the calculator, I get 141. Plugging the denominator in, I get this. So to solve for A, I will take cos inverse of both sides. And A is approximately 87.95 degrees. Okay, so now, in order to find the next angle, I can either use the law of cosines and find either angle B or angle C, or I can use the law of sines and find angle C. Personally, I think using the law of sines is significantly easier, so that's typically what I do. I just make sure I get in the habit of finding the smaller angle first. So I have to use the angle I just found, which is 87.95. Again, trying to use the exact value rather than the approximated value. This is divided by 62 is equal to sine of C divided by 41. So I'll find that C is approximately sine inverse of 41 sine of 87.947 degrees, all divided by 62. And this is approximately 41.366. Now, I have two of the three angles. I need to find the third angle, which is angle B, by subtracting the two that I have just found from 180 degrees. So when I subtract these, I get approximately 50.7 degrees for that last missing angle. Well, of course, we're going to have some word problems that involve the law of cosines. So pause this and take a moment to read through. The first thing I would recommend doing is sketching a picture. And as you can see here, bearings come up again. And so you'll want to sketch a picture that is big enough so that you can see what's going on. So let's say the origin here is the airport. The first plane leaves at 3 p.m. and averages 450 miles per hour. And it is at a bearing of south 70 degrees east. So this here is 70 degrees. And then it says a second plane leaves at 5 p.m., averaging 510 miles per hour at a bearing of north 10 degrees west, which would be here. And we want to see how far apart these planes are at 6 p.m. Okay, so let's calculate a little more information here. We know this side is, if it leaves at 3 o'clock and we want to find how far apart they are at 3 p.m., that's 3 hours. So 3 hours at 450 miles per hour will tell us, so multiplying this, we will get 1,350 miles. Okay, so that side, let's just sketch this here. I'll call this A, B, and C. So this is 1,350. Okay, now we want to do the same thing over here, this side. This is just 1 hour from 5 to 6, and that's traveling at 510 miles per hour, so this is 510. Given the information, the other thing we can find is angle A, and here's how. We know this angle is 10. We know this is a right angle, so that's 90 degrees. And we can find angle star by taking 90 degrees minus the bearing of 70 degrees, which will give me 20 degrees. So 10 plus 90 plus 20 will give me an angle of 120 degrees for angle A. Okay, well, we want to find how far apart the planes are, which would be side A in this case. So if I know angle A, I can find side A by using the law of cosines as follows. A squared is equal to 510 squared plus 1350 squared minus 2 times 510 times 1350 times cosine of 120 degrees. So A squared is, I think that's actually exact. 2,771,100. Then, oops, this is A squared. Then we'll take the square root of both sides and find that A is approximately 1,665 miles. So if I were answering this question, I would say the two planes are approximately 1,665 miles apart. Okay, so in this one, we are talking about the distance between several cities. And let's go ahead and label this. So the distance between Miami and New York City is 1,093 miles. I have no idea if this is accurate or not. The distance from New York City to Nashville is 759 miles. And the distance from Nashville to Miami is 816 miles. I'm going to go ahead and label this triangle as A, B, and C. And we are asked to find the measure of each angle between the towns. Okay, so if I want to do this, typically we will find the largest angle first, which is angle A because it's across from the longest side. So applying the law of cosines to find angle A, I'll have 759 squared plus 816 squared minus 1093 squared all over 2 times 759 times 816. To get A by itself, just to save some writing, I'll take cos inverse of both sides, and we will find that A is approximately 87.8 degrees. Okay, now either angle's fine, it doesn't matter which one. Typically, I was showing you the use of law of sines. I'll just show you using law of cosines, and I'll find angle B. So in this case, cosine of B is equal to 759 squared plus 1093 squared minus 816 squared all over 2 times 759 times 1093. Cos inverse of both sides to get B, and we'll find that B is approximately 48.247 degrees, and you can round that if needed. And then lastly, we'll find angle C. Angle C is found by taking 180 minus the two angle measures that we have just found, and that is approximately 44 degrees. So we have just answered that question. Here is the formula that we will use to find area when we are given all side lengths. We have to use a different formula than the previous formula that we found for finding area because we don't have an angle measure. So if we're given all three sides, here's the formula we use. We will need to calculate S, and S is the semi-perimeter, which is found here. So you'll find S, you'll plug it in for each of these, and then subtract the sides. So our first example of this says find the area of the triangle formed by the three cities in this exercise. So recall that we had, this was 759, this was 816, and this was 1093. So the first thing I need to do is find S, and S is found by taking half of the sum of those values. So we will add these up and then divide by 2. And when we do, we find that S is 1,334. That is not the area, but that will help us find the area. The area is found by taking the square root of S times S minus 759 times S minus 816 times S minus 1093. Plug this into your calculator and you'll find that the area is approximately 309,446. Since we are finding the area and these values are measured in miles, my final answer will be in square miles. Pause the video and try this one. In order to find the area given 3 side lengths, the first thing I need to do is find the semi-perimeter, which is 1/2 times the sum of the sides. So 15.4 plus 22.6 plus 26. When I add those together and divide by 2, I get 32 for S. So then, to find the area, I'll take the square root of 32 times 32 minus 15.4 times 32 minus 22.6 times 32 minus 26. Plugging this into your calculator, you should have found that the area is 173 square meters. This concludes the information from section 6.3 and chapter 6.